Hi everybody, welcome back to Problem Solving Part 2. So in the last section we were talking about top-down processing and heuristic approaches. If you add on to that and think a bit about a different sort of problem solving, which is also the Gestalt problem solving, is the question about whether or not we solve problems by sudden insight. So the idea is that in the background, our brains work to solve problems kind of outside of our awareness a bit. And Kohler did some studies trying to look at how this process may work. He initially did this with chimpanzees because he was stranded on an island during World War I, and those were the subjects that he had. So what he did is had bananas hung from a ceiling, had some crates just kind of strewn about, and then wanted to see whether or not the chimps could figure out how to get to the bananas. Well, as many of us probably have encountered, if a helium balloon floats up, first thing we do is kind of jump, and then we realize that it's way too high, so we don't know why we're jumping. And then in the particular case here, the monkeys did the same thing. Well, they tried it for a while, they got really irritated about it, and would go sit in the corner and just sort of rock back and forth. Until some period of time passed where Kohler noticed that the monkeys would jump up, grab the crates, stack them, and then get the bananas. So it seemed that they had experienced this sort of sudden insight about how to solve the problem. So this Gestalt view of problem solving involved these 4 basic stages that are important for you to understand. They look like this. First, when somebody is trying to solve a problem, is the preparation stage. So this would be like the jumping up trying to grab the bananas. You try some preliminary attempts to solve it, then it doesn't work out. The second stage is after the attempts fail, you give up for some period of time. And the key here is that you're not consciously thinking about the problems during that stage. It's as if you are unaware that your brain's working on them. The third is illumination, where this is the sudden flash of insight, where the monkey jumped up and knew what to do. This would be all of a sudden, oh, you know how to solve the problem. And then you verify to confirm that your insight solution actually works. So this is an example that everybody can think about where you've maybe had some issue you didn't know how to deal with, and you get irritated, you stop thinking about it, and 2 days later you're in the shower washing your hair, and all of a sudden you have the answer. So this is an example of that kind of problem solving. So the part here that is suspect is that incubation is something just like imagery where it's internal and there's no way to know what's really going on in somebody's head other than what they report. So you don't really know what's going on in the incubation stage. So there have been some studies trying to look at or find a way to infer what's going on in the incubation stage. So one study Silveira did, which is called the cheap necklace problem, is going to be used in the next couple of studies. And so what she did is she gave people these 4 links. There was all sorts of rules about how many times they could open the links and close the links. But the up and the short of it is they had a gold stake necklace they had to make. And so they had to figure this out in a given period of time. So to do this, she separated subjects into 5 different groups. There was the first group, which was the control group, and they just worked to try to solve this problem for 30 minutes, and then she just measured how many people did it. There were 4 experimental groups. The first 2 groups worked for just a little bit, so 2 minutes, and then one got a 4-hour interruption. The other group got a 30-minute interruption. And then there were another set of experimental groups where they worked for 30 minutes, and the idea was long enough for them to become frustrated. Then one group got a 4-hour interruption, and one group got a 30-minute interruption. And the question was, who solved the problems the most frequently? So in the control group, they were given just the problem and no incubation period or anything, and a little over half of the people solved the problem. In the experimental groups where they only worked for 2 minutes, there was no incubation shown, and the solving rates were about the same as control. control, so there was really no difference there. The interesting thing is, though, in the other experimental groups where they were given 30 minutes to try to work on the problem and seemed to get frustrated, it showed some incubation in that the first group, where they only got a half an hour break, that was 64% of solving. But you can see that after a 4-hour delay, where they're not thinking about this for 4 hours, there's a substantial jump in the solving rate. So the questions we have here are, if we do solve problems using insight, can we tell, this is the metacognition piece when it's coming, is that it's called the feeling of future knowing. Do we know when we're going to be able to solve a problem? So this would be an example where if I were to say, okay, think about the guy who was in all the Terminator movies, the main actor. And let's say you can't think of his name, but I said, hey, if I showed you a list of a whole bunch of actors' names, do you think you could pick it out? And then your ability to say, yes, I think if I saw his name on a list, I could pick it out, would be an example of metacognition, your understanding of your future knowing. So in testing this idea, metacognition, they used what's called the Dunker box problem. And so this is a problem where people would be given some materials like this, and then the question is, can you mount this candle on a bulletin board and be able to light the candle? People are given some period of time to do it. And then this is the actual solution to the problem. So functional fixedness blocks what you need to be able to see how to do the problem. If you can only see the box as something that holds things as opposed to a shelf, then you're not going to be able to solve the problem. So to test this, Dunker presented this in 3 different ways. One was a control group where the box was empty, nothing was there to confuse people, and they solved this problem 100% of the time. In another version of this was called the fixedness version, where everything that you just saw in the example, what they needed to solve the problem, was sitting there, and only 43% of the people could figure it out then because they were unable to see the box as something other than to hold things as opposed to being a shelf. And then there was the neutral condition, which I consider the mean condition, where they actually had things that were irrelevant to the task also in play, like they had buttons and things sitting around, so people feel like they have to figure out how to use a button to solve this problem. And in doing that, it really reduced the likelihood that people could solve it. So the question is, with regard to metacognition, Metcalf and Levy had this idea that if there really is a difference between insight and non-insight problem solving, then you should have no idea that the answer is coming if it's an insight problem, because that's one of those things where it just jumps to mind. However, non-insight problem solving, you can tell when you're getting close to a solution. So they sought out to test this. The plan was to test this idea of metacognition using the cheap necklace problem like Silveira did. And to do this, in addition to having to solve the problem, they were measured every 10 seconds by some really irritating experimenter to say, how close are you to solving the problem? How hot are you? Meaning that if you're cold, it was, I have no idea how to solve the problem. If you were super hot, then you were saying, I'm really close to solving this problem. So people that were in the experimental condition were trying to solve the necklace problem, and then they were stopped every 10 seconds to get a warmth rating. Alternatively, people were doing a non-insight problem, which would be like just solving math problems, and the idea is if you know how to solve the math problem, you know how many steps it takes to get there, it does not require any insight. So here's what the data look like, which is really cool. So this is in the last minute of the test. And you can see, if you look at the algebra problems on the left-hand side, the warmth ratings, which are the dark blue bars, are consistently moving from cold to warm in the last minute, and then the problem is solved. Alternatively, if you look at the insight problems, you can see that they look cold 60 seconds out, cold 45 seconds out, 30 seconds out is cold, 15 seconds out, and all of a sudden they're like, aha, and then they solve the hindsight problem solving really does have the sort of aha effect, and you don't know the solution is coming. And that's pretty cool.